Welcome back to All This Math. This is Professor Parker, and today's lesson is brought to you by this brother who's on my shirt right here, Frantz Fanon, the late, great Frantz Fanon. Now, if you're unfamiliar with Frantz Fanon, that's cool. A lot of people are unfamiliar with him. Frantz Fanon was a Pan-Africanist psychiatrist, born in Martinique, which is in the Caribbean, educated in medical school in France, and then ended up going to Algeria. And instead of trying to become one of the French and being colonized and trying to become one of the French, he realized the necessity for working against the French in anti-colonial struggle. He wrote several books. His probably most famous book is The Wretched of the Earth, which was read by many of the Black Panther Party members when they founded the Black Panther Party back in 1966. He also wrote another very important text called Black Skin, White Masks. Also, Toward the African Revolution and also A Dying Colonialism are four of his books. He may have written more, but those are four that I remember off the top of my head. So today's lesson is brought to you by Frantz Fanon. Please get familiar if you're not familiar with him already. All right. Now, this right here. We're going to get into this, some of this quote unquote new math that makes parents upset. All right. Now, but what I want to do is I want to break it down for you and show you how to do it. So this video is not necessarily just for the young people. This is, I think, being taught like in 5th grade, right? 5th grade, maybe 6th grade, between 4th and 6th grade. This skill is being taught, right? I'm going to break it down for you and show you how, maybe it might already be something that you already been doing anyway as a parent, right? If not, it's something I think that will help you because it makes math that you normally would have to take out a calculator to do or write down and using the standard vertical multiplication algorithm, right? It makes it so that you can do it mentally, and it's not that difficult. All right, so we're going to do this problem a couple different ways, right? The instructions are to convert to unit form, what they call unit form in some textbooks and in some curricula, unit form for mental math. All right, that's the goal, mental math. So we got two-digit numbers, right? 13 times 17, right? Now, again, we're not going to write this down, 13 on top, 17 on the bottom, do the thing, boom, 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 and then do the two rows, add them up. We're not doing that. We're trying to figure out ways to do this mentally. All right? So what we want to do is we want to look at one of these numbers. Let's take the 13, right? Let's take the 13. We want to create an expression that includes what I call a happy number, right? A lot of teachers use the term happy number. Happy numbers are numbers that end in 0. What makes them happy? They're happy because it's easy to multiply numbers that end in 0. It's easy to add numbers that end in 0. All right? That's what makes them happy. It makes you happy because you end up doing less work. You know what I mean? So look, I'm going to change 13 to an expression that includes a happy number. Now, I got to think to myself, what would be the closest happy number to 13? 10. So I'm going to change 13 into 10 plus 3. See, because 10 plus 3 is 13. So I'm changing 13 into an expression that includes a happy number. I could have did the same, I could have did the same thing with 17, but for now, in this example, I'm going to break 13 down in a certain way. So we got 10 plus 3 times 17, right? Now, then comes this rule or this property that children often don't get introduced to until they get to algebra, right? But they should get introduced to it early on. And actually, they are introduced to it early on. The teachers may just not call it that, right? But I advocate for us being straightforward and explicit and calling it what it is. The distributive property is going to be used next. The distributive property. Because basically what we're going to do is we're going to distribute the 10 to the 17 and the 3 to the 17. Or you can look at it the other way and think of it as distributing the 17 to the 3 and the 17 to the 10. But I'm working left to right. So I'm going to just think of it that way. So now, what we're going to do is think about it. 10 times 17 and 3 times 17. I could rewrite it like this. 10 times 17 plus, because there's a plus sign in between the 10 and the 3. 3 times 17. So what I want you to do is like pause the video for a minute, right? And make sure you understand how we got from this original expression to this right here, right? Make sure you understand the connection between this and this and this, because this really is a representation of another property called the transitive property. If A equals B and B equals C, then that means that A is equal to C. So look what we did. All I did was I took this 13, I broke it down into 10 plus 3, because we all know that 10 plus 3 is 13, right? And I'm still doing times 17. I'm still multiplying by 17. Boom, 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 boom. Now, then I'm going to do the distributive property because this also means that I'm doing 10 times 17, and I'm also doing 3 times 17. So I got 10 times 17, and I got 3 times 17. Now, this is the fun part, right? Because I can easily do 10 times 17. We all should be able to easily do 10 times 17, and this is why. Because 10 times 17 ain't nothing but 1 times 17 with a 0 attached to it. That's all it is. That's all it is. So that's why, again, 10 is a happy number because it makes our math easier. It's a number that you can use that makes your math easier. And we're happy when the math gets easy, right? So if 10 times 17 is just 1 times 17 with a 0 attached to it, then that means that 10 times 17 is 170. Boom, so that's 170. Now over here, 3 times 17. Now if somebody knows their 17 timetables, then they would know that 3 times 17 is 51. Most people don't know that though. And that's cool. That's cool. I'm going to show you how to figure that out. But basically the same way we did this. If I do 3 times 17, right, I'm really doing 3 times 10 plus 3 times 7. Check that out. 3 times 10 plus 3 times 7. Because 10 plus 7 is 17. If 10 plus 7 is 17, then 3 times 17 is just 3 times 10 plus 3 times 7. That's all that is, right? Now, over time, with a lot of practice and doing this and adopting this method and applying it a whole lot, you'll begin to be able to do this on a regular basis using mental math. I'm trying to tell you, right? I do this all the time, and it's not because I'm a math teacher, right? It's because I've just practiced this skill, right, over time. Now, we got 170, and then 3 times 10 is 30, and 3 times 7, we should know our 3 timetables. You should know your 3 timetables, all right? If you don't know your 3 timetables, go to allthismath.com, click on the printables, open up the 12 by 12 PDF blank multiplication table template, print them out, and fill one out. You know, just practice with them, fill them out every day on a daily basis. I'm telling you, thank me later, all right? Now, 3 times 7 is 21. Now we just add everything up. Add everything up. 170 plus 30, that's 200. 200 plus 21 is 221. That's our final answer. Now, I know we wrote a lot, I was talking a lot, but I'm telling you, if you practice this method over time, you'll be able to quickly and easily do this with mental math very quickly. But it will take practice. It will take practice. It's not going to happen overnight. It will take practice, I'm telling you. So this is 221. But now I want to do this another way though. I want to show you because we could have broke down 17. We could have broke 17 down, right? Instead of 13. So let's say I'm going to write it again. 13 times 17, right? And let's say I'm going to make a happy number expression with the 17. So I'm going to leave the 13. And what's the closest happy number to 17? It's 20, right? Closest happy number to 17 is 20. So I could represent 17 by saying 20 minus 3. Because yeah, when we create those expressions, we can create an addition expression or a subtraction expression. We can create either one, right? Whatever we need to do so that we have a happy number, right, that is within the expression that will, and another connected to another number that will yield us the number that we started with. So in order to get 17, if I involve 20 in that conversation or in that process, I can't add 3 because that would give me 23. I would have to subtract 3. So I got 13 times 20 minus 3. 13 times 20 minus 3, right? 13 times 20 minus 3. So now, again, distributive property. 13 times 20 minus, because it's a minus sign now. Before it was a plus sign, now it's a minus sign. Minus 13 times 3. All right, now let's go in on this one. Now, 13 times 20 seems a little complicated, right? But all 13 times 20 is just 13 times 2 with a 0 attached to it. So whatever the product of 13 and 2 is, you take that, you attach a 0. That's all 13 times 20 is. So 13 times 20 is going to be, first we got to think, okay, what's 13 times 2? Learn your 13 timetables, all right? 13 times 2 is 26. But let's say you didn't know that, all right? 10 times 2 is 20. 3 times 2 is 6. What's 20 plus 6? 26. Put them together, you get 26. Again, 13 can be broken down into 10 plus 3, just like we did up here. 10 plus 3. Multiply them by 2. For the meantime, we're pretending that this 0 is not here. We're pretending that this 0 is not here. So 13 times 2 is just 10 times 2 plus 3 times 2. So that's 20 plus 6, which is 26. But we got to connect that 0. So actually, 13 times 20 is 260. 260, right? It's 260. So now we go over here to the 13 times 3. 13 times 3, if we know our 13 timetables, we know that 13 times 3 is 39, right? But let's say we didn't know that. We use the same skill. We break it down into what they call unit form. We break 13 down into 10 plus 3 again. We do 10 times 3, we get 30. 3 times 3, you get 9. What's 30 plus 9? 39. Put them together, you get 39. So we're really doing 260 minus 39. And again, now we're doing 260 minus 39. We want to use mental math, right? But we say, okay, that looks a little confusing. But what if we broke it down like this? 260 minus 30 minus 9, right? What if you took the 30 away first and then took the 9 away from that? 260 minus 30 is 230. And then 230 take away 9 is 221. And that's another way to get the same answer, right? Unit form. So again, if you have a child in 4th grade, 5th grade, 6th grade, and they come home with this homework, and you like, yo, I don't know what to do with this new math. Oh my God, right? Don't fret. You know, if this is what they have to do, hopefully that kind of gave some context and kind of gave an explanation of what you got to do. Basically, all you're doing is you're creating an expression, right? Using what I call happy numbers. And happy numbers are numbers that end in 0, right? And why are you doing it? So you should understand why. Like, you know, don't just take the procedure, but understand why the procedure makes sense. Why you do it? Because it makes the math easier. And it makes it easy to do the math mentally, right? So 13 ain't nothing but 10 plus 3. I mean, we could have kept it going. We could have did this another way. We could have broke 17 down into, well, we did break 17 down into 20 minus 3, but we could have also broke 17 down into 10 plus 7. We could have also broke 13 down into 20 minus 7, right? Dealing with happy numbers, you know, dealing with the happy numbers. That's really all this is, all right? So, again, I hope that this made sense. I hope that this was valuable to you. And check out Frantz Fanon. Check him out. Especially if you never heard of him before. Actually, and if you heard of him before, but you haven't, you know, had the chance to really, you know, get into Wretched of the Earth, really get into Black Skin, White Mask, or some of his other work, go revisit his work. You know what I mean? There's some readers out there, some biographies written about him. Definitely, you know, dig into him. Check him out. Very influential. He has some very powerful ideas. All right, that in this day and age we definitely should at least familiarize ourselves with. All right. So again, if you have not subscribed to the YouTube channel, please go ahead and subscribe to the YouTube channel. Like the video if you gain value from it. Share the video with somebody else. If you're a parent looking at this, share it with one of your friends, you know, that has the same complaint, you know, about the new math out here, right? You know, share it. Tell everybody about it. You know, let everybody know what we're doing at All This Math. Subscribe to the channel, like the video, turn the post notifications on because we're putting up content on a regular basis, and make sure you're notified when some new content comes up because you never know, that video that you get the notification for might be the video that you need to help your child with their homework. All right, on that particular night. All right, so as always, remember, there's all this math all around you. Peace.